Hi everyone, and welcome to this last video where we talk about plotting functions or graphs of a function. And this is the last video of precalculus. From next week, hopefully we'll be posting calculus videos. So graphing is pretty important when we try to visualize what we are really doing in calculus. So I'll discuss the very basics of graphing, and then I'll move to Wolfram Mathematica, the software I use on a daily basis, to show you how different graphs look like. We are just trying to develop some intuition for graphs. That's it. That's all we need to do right now. All right. So let's say you have a function y equals to f of x. The question is, how do you plot it, or what does it mean by plotting? So plotting means, let's say you have some input data for x, and once you give some input to x or some numbers, the function itself will generate some outputs, right? Your output data. So plotting really means is that you show in a visual way how this input corresponds to a certain output. All right. So I guess everyone is familiar with the two-dimensional Cartesian coordinate system. We'll only consider that. Calculus like uh, multivariable calculus most ideally. So for now, this is enough. Just considering the Cartesian coordinates, that is x, y, and negative y. And you can make some grid lines like this. Just your ordinary graph paper and stuff. So how do you plot functions now? Again, my drawing is very horrible, as you can see. Each of these rectangles are just one units. Like if you move around horizontally, you move from one point to another in the x-axis, and when you move vertically, you move from one point to another in y-axis, okay? So let's take something like this. Let's not consider a function, like some sort of a relation like this. That is 1, 2, 3, 4, 5, 6. Let's say 1 goes to 4, 2 goes to 5, 3 goes to 6. Now, in ordered pair, we wrote them like this, where this was our x. Again, this is x, this is y. So where is 1, 4? 1, 4 is somewhere over here. Again, this, okay, let's just get rid of this. Since my drawing is not according to scale, so I'll just use my intuition to plot the points. So let's say this is 1, the x value 1. And to find y, we have to go 4 units above. So 1, 2, 3, 4. Let's say 4 is somewhere over here. So this is 1 point over here, 1, 4. And 5 might be somewhere over here. And then we can similarly plot 3, 6. So 3 is somewhere over here. And y value of 6 is somewhere over here. And there you go. That's your plot. Now, this is a discrete example because you have only 3 ordered pairs. But if you have many more, that's those are the things that will be of interest to us because calculus is a study of continuous things, and we really want to focus on continuous functions. So let's try to see how we can plot y equals to 2x. Okay, again, you can take a graph paper and find the grids. You can take different input values of x and list the corresponding y values. Let's say 0, this is 0, this is -1, this is -2, this is 1, this is 2, this is 2, this is 4, this is 3, this is 6, and so on. Once you have enough points, you will see when you plot them, like mark the points, they will look something like this. All right. And now you are almost done. But since this is a continuous thing, by continuous, I mean x can take any value after 0, right? It can be 0.01, it can be 0.001. So all these places will have some points. So the idea is that Once you figure out a few points, you just join them in a smooth manner. That's how you draw the graph of y equals to 2x. And obviously this is a straight line with the y-intercept as 0, okay? Another famous example is the equation of a circle, x squared y squared equals to, let's say, 4. Now you can solve for y as plus minus 4 minus x squared. Now you can take different inputs for x and different inputs for, sorry, different outputs will be at the y value, and it'll look something like this. Let's say this is again our xy coordinate, and this is how it will look like. We're not getting into details of, the radius and the stuff, so everyone knows that. Anyone who has done coordinate geometry knows that this line will be of 4 units, okay? So this is how you plot things. This is very simple. I'll go into Mathematica, but before I do that, in one of our videos, I mentioned that there is a graphical test of whether there is a whether the relation is a function or not, and it is known as the vertical line test. And let me show you how does that work. So let's say you have a graph, let's say something like this. This is some sort of a parabola. The vertical line tells you that, and you can guess the equation. For us, it will be something like this, y equals to x squared. As you can see, you can take 1, let's say this point is also 1, and if you take minus 1, this point is also 1, right? So this is a relation for now. We want to know whether this is a function or not. Well, analytically, using some test values, you can say, oh, this is a function. But let's say I don't give you the equation, rather I give you a graph and I ask you whether this is a function or not. What do? Remember that in the definition of the function, we said one input cannot have multiple outputs. Using that in mind, what we can do is that we can, and we want to see whether this vertical line intersects this graph, this one, the red one, at two different points. That is, whether this vertical line crosses the red line once or twice, or more than once, so to say, once or more than once. That's what we want to see. In this case, we can draw as many as vertical lines as we want, but we will see it only crosses the red line only once. So that's the criteria of this red line, or y equals to x squared is a function. That's the criteria. It satisfies this, so that's why we call it a function. Now, let's now consider the circle thing. And now if you draw vertical lines, one vertical line is good enough. By vertical line, I do mean parallel to y-axis. So let me label the axes. And as you can see, it has 2 points. This one, let's call it point A and B. So what is happening here is that for some input over here, we have 2 different outputs, right? And the vertical line is just telling us graphically where these 2 points are at, where these 2 outputs are at. So in this case, we say, oh, this is not a function. Rather, it's a relation. So that's how this vertical line test works. Now, there is another thing called a horizontal line test. And horizontal line test is used for to know whether your function is a one-to-one function or one-to-many function. So the idea is, again, something very similar. You have your axis, you have some plots like this, let's say, And then what you do is that you draw a line or multiple lines parallel to the x-axis and see whether they intersect once or more than once. As you can see, it has intersected, more than once. Obviously, you can draw more lines like this, and it will show you the same behavior. So in this case, we say, oh, this is a function because if you do a vertical line test like this, you see the vertical line once. So since the plot itself crosses the vertical lines once, this is a function. However, when you draw some horizontal lines, the plot crosses them more than once. So even though this is a function, this is not a one-to-one function, okay? So that's what the horizontal line test is for. I didn't want to discuss it, but then I thought, why not, right? For the sake of completeness, we can um, discuss it. All right, now I'm done with my tablet. I'll just show you some different graphs for different functions. So let me close this tab and open Mathematica. This is a software that I use for my daily work. It's like my best friend, I guess, nowadays. So you can use any software you want. You can use Python, you can use Mathematica. If you're interested in Mathematica tutorials, I'll put a link down in the description box that something I made back in the days. It's some Mathematica tutorials. It deals with the basics and stuff, and obviously some advanced stuff as well. So if you're interested, do check that out. I'll really appreciate it. All right, so we want to plot functions. So let's give a header called plotting slash graphing functions. Oops. Now, what sort of functions should we plot? Let's say I want to plot a function, so I'll call plot. And let's say I want to plot something like this, 2x squared minus 3x plus 2, a quadratic function, okay? And let's say I want to see the plot from minus 10 to 10, and I want my plot theme to be a little bit detailed. I like it that way most of the time. And as you can see, this is a plot. I can do more options. I can do, let's say, plot range. Let's say all. I want to see throughout the whole range. So this is what it shows me from minus 10 to 10. All right. Now let's say I want to see another function and, just compare what happens if I take the same thing, but instead of plus 2 in front of x squared, I put a negative 2. And let's see how this thing unfolds. As you can see, this brownish line is your negative 2x squared minus 3x plus 2, and this is your blue line. And now let's say I want to plot something more. Let's say I want to plot a cubic function. So x cubed minus, let's say, 3x squared plus 5x minus 12. And as you can see, there is another plot of the function that I just input, and it's showing me from minus 10 to 10. So yeah, this is how you can plot things. Like, you can try any software that you want or any online resources, any online websites, and some of them even have some animated things that they show you how this points gets plotted and so on. In fact, I can show you one animated plot, I guess. So let me try to do something. So let's see if I can actually do it. So let's say this is ax squared plus, let's say this is bx plus c, and I want to plot it from minus 5 to 5, where my values of a will be taken from 0. When this is 0, this is just a linear function. So at a equals to 0, that should be a straight line. So let's say it's from 0 to 3. And again, I'm going to take b from 0 to 2, let's say. Again, when a and b both are 0, this is just a constant function. So it should be just parallel. It should be just a parallel line, like a straight line. Yes. And finally, I can take c from, let's say, again, 0 to, or maybe to get something less boring, let's say from -2 to 4. All right, let's see if this works. Okay, this is working. However, the plot range is not very good. So let me fix that first. And then we'll get back into the animation. So plot range, automatic. Okay, okay, let's now run this. All right, so I'll just use this. Oops, I didn't mean for that. I just want to zoom out. All right, so we have three parameters, right? So let's get B and C. Like if I expand this, is it forward button? Nope. Okay, so let's try to keep B at 0 and C at 0. So these are sliders. They help me to visualize what's really going on. And now if you vary A, as you can see, when A is 0, this is -2 because C starts from -2. So that's the lowest value of C. Now if you start to increase A, let's make it a little bit slower. Let's play. Okay, you can see these numbers are moving up and down. It's because the value is changing and how this is going upward, and obviously this will be a parabola. Now what you can do is that now you can put A to 0. However, now you can increase the value of B. So let's say I'm slowing it down. Now play. As you can see, this becomes a straight line. As soon as B picks up some value, it becomes a straight line, and it will stay as a straight line because our A is 0. And if you put B equals to 0, and just keep continuing to increase the value of C, this is how it works. And if you let all of them vary, like A sum this, B sum this, as you can see, it's getting stretched out. That's what we expect. And C just controls whether it's moving up or down. So that's how you can plot functions and visualize different sort of stuffs. And this will be it for today. And from the next lecture, we'll be posting calculus stuffs. Calculus 1, that is single variable calculus. We'll start with some very basic stuffs, introduce logarithmic and exponential functions, and then we'll discuss limits, differentiation, and all this stuff. So stay tuned, and if you think you have enjoyed our content, do give a like, subscribe for more. Your support helps us to go a really long way. Thank you, and have a blessed day.